Okay, Lady Ada, what is this?
Hey, everybody, and welcome to a Wednesday night show and tell, decade strong, live broadcasting every week on Wednesdays at 7:30 p.m. It's me, Lady Ada. With me is Mr. Lady Ada. We're here at the Adafruit headquarters. That's right behind us, where we do our testing, shipping, and manufacturing. But for the next 25 minutes or so, we're going to check in with people around the world to see what they're hacking on, people from the Adafruit community, as well as people who work at Adafruit. And we'll see what goodies they're up to, maybe some gaming, some previews, and some spooky stuff. Let's start off with Melissa. Melissa, what are you up to?
Hi. Okay, I am working on getting Tensorflow working on a Raspberry Pi here. And so I got a camera here. And I want to share my screen here. Let me see how to do that. See if this works. Okay, here we go. So I can kind of, can you see my screen here?
Yeah.
Okay, so I'm gonna hold a item in front of here, and you can kind of see it like trying to detect. So I got this syringe here, and I noticed that was one of the items on there.
Yeah,
so
it says about 20%.
It's kind of getting confused with multiple images, things on there at a time, but.
Well, there's a lot of stuff.
It's a quill. It's a wig. It's a photocopy.
It probably thinks your hair is a wig.
It's a dishwasher.
It does. It does, because my hair is long.
It does say syringe with 98%, so that's pretty good. Like when you hold it up right.
There we go, in front of it.
So it's fire now.
Okay. All right.
Anyway, so that's what I got working on there today. So I want to get OpenCV working on here too, so that it'll actually show little boxes around the items on the little LCD.
Okay. Making progress. Good work, Silky Terrier, Offen Pincher, and Drumstick. That's my new name for you, Drumstick. No, just kidding. All right, thanks, Melissa, for the update.
All right.
I think what's funny is your hair. You know, you have this like luxurious long hair, so it's like you're a wig or like an Afghan hound. You know, it's like this kind of luxurious pet. It's such a bad life, you know. Like if we could all be born as dogs, I think we'd be much happier people. All right, thanks, Melissa.
Thanks.
Next up, let's go all the way to the spooky side with JP.
Hey, all right. Let's take a look. Are you showing my?
Yeah, we're showing you their video camera, which is terrible.
Mask image, yeah. So how about that? Huh? So what I'm going to show is, let me switch over to my camera now, and you can see me over here. So what I'm going to show on my show tomorrow is how to take a pretty typical vacuum form Halloween mask or any other kind of costume mask, could be something fancier, and add your monster mask to it in a really nice, comfortable way that allows you to still see a little bit under the eyes and wear this nice foam against your forehead rather than pressing a bunch of components and PCB into you. So this is pretty quick and easy to make, and it's perfect for creeping everybody out.
And you can actually see below. You have like a grill, or
yeah, I can see below. So there's a grill on here, and you could add this yourself or some masks. This one's meant to have dead eyes. It's based on a horror movie called The Strangers. So this mask comes this way so that it's sort of blacked out.
Oh, I see. So you can see the eyes, but you can see out just fine.
Yep, you can see out really well, just like any sort of stretched thin black mesh material. And so this really enhances the effect because I'm seeing out of it underneath these. It actually makes the mask a little more comfortable because it's pushed away from your face a little bit. And normally this mask kind of suffocates you. But I think this is a really nice example of how creepy the eyes can get if you use your monster mask and customize your eyeballs on here, and very easy to put together.
Yeah, that's absolutely horrifying and wonderful at the same time. Well, Halloween starts in 2 days on September 1st, as everyone knows. So you're ready to rock.
We're almost there.
I know. I can't wait. All right, thanks for the spooks.
You bet. Come by tomorrow and check it out on my show.
And more. And you'll be doing a lot more fun Halloween projects in the next 2 months of Halloween, September and October.
We're gearing up.
Yeah, 2 months of the year. That's not so bad. 1/6 of the year is Halloween.
Yep, it's reasonable.
And then there's a post-Halloween. Okay, known Pedro, what are you guys 3D printing?
Yep. Hey, folks. So this week we thought we'd get to this solder dispenser project. So we made a solder dispenser a couple of years ago, and then cranks happened.
Pranks happened.
We had to make
Things are so hot right now. I guess I put that on.
It was the top comment. So I got my little Adafruit here. He's got some solder in there, and he's got a snap fit cover. And the crank is pretty much the exact same crank that we used in the crank project. So I got some solder here. It's got a little spool holder, and it snaps in there with the snap fit part, so I can pull out my solder wire. And Lamar, if you want one, let me know. I'll print you one.
Yes, of course. I like that. The thing that I like about it, it's not that you unwind it, of course, because you just pull it if you want to get solder, but to crank it back when you're done, that's kind of nice.
Yeah, because then you have to unwind it. So there we go. It's a really fun little print. You can print it in different colors, or you can dual extrude it as well. But I just think that the crank is really nice. We're gonna do some more stuff with it. So.
No, you're like you make a thing and then you're like, I'm using this thing.
I'm gonna crank.
I'm gonna crank the heck out of stuff.
The crank. There you go.
Your name.
All right, well, looks cool. We got a lot of exciting stuff coming up.
Yeah, another cool things we get to we played around with Instagram filters. So shout out to Stephanie on YouTube who made a tutorial, and we followed it, and we made our own Instagram filter. So if you go to the Instagram Adafruit page right here, there's a little tab with a little happy face. Oh, look, the Bleaker one. Sweet. Oh, and
they are now activated. Yeah.
So you can wear NeoPixels or a Monster Mask if you want to try it out.
Cool. Right. You can literally click try it and it'll download it. And there I am.
Oh my God.
That's the first time seeing it. Nice.
That's insane. So these are actually the PCB files, the Eagle board files that are.
I love it because it's like we have these PCB files. And it's like, yeah, they're handy, but now you're like. You really
I can use them. That's so great. So we also did an Adabot version, so we could take the weekly projects and like.
Does that actually work?
Let's see. What is that? Oh, it's a different filter.
Oh, the scaling is wrong. You can
No.
kind of see, like, you can go inside, you can play back animations.
So we're having a blast.
Cool.
Instagram.
Yeah,
You're having a good AR time. No, it's like a little friend. It's like, hi, I'm Lily.
Let's see if it loads. Oh no.
Yeah.
If I'm back. Oh well.
Yeah.
No,
AR scaling is funny.
No, it's like inches or centimeters.
Well, try it out and let us know, and maybe y'all can we'll make a guide or something so you guys can access it.
So if you go on Instagram and you go to instagram.com/Adafruit and you follow, click the little face, and that unlocks all the effects.
Yeah.
You got it.
All right.
Sweet. Don't forget, we did a hangout show. Check that out. That was fun.
Yeah, and we'll be playing some of the videos and more on Ask an Engineer tonight.
Awesome. Thanks.
Awesome.
All right,
Thanks,
thank you.
Bye, everybody.
So let's go to Scott now.
All right, next up, let's go check out what Scott is doing. You got Game Boys, you got...
I got all sorts of gaming stuff. I'm going to PAX West on Friday, which is here in Seattle. I'm going to check out the Playdate for sure, but I wanted to show off some gaming on CircuitPython devices. These are ones you've seen, PyBadge and PyGamer. The thing I wanted to point out is that we have different refresh API now in CircuitPython that makes it this level in particular is tough because all of these little blocks are seeing if you're on it. So it causes it to be slow. Now, I don't know if is that any better? It's a little bright.
No, we can see it. Yeah, I can see the character. Okay.
But basically, it's better about keeping the speed of the character even when it's dropping frames. You could see, like, as I fell, it was slower. But the overall rate should be better now than it was before. It used to just run really slowly overall.
Yeah.
And now it's like much better.
So the new refresh control. So like, how is it different than what it was last week?
So what it was before is that you'd say like, oh, wait for frame, and that tried to keep you at a particular rate, but right now you can actually set what that rate is, whereas before it kind of just would refresh whenever you wanted to, which would mean that like, oh, maybe like refreshing the screen is not cheap, and it might have done it when you didn't want to, like when half the screen was updated. So now you can be explicit about when you want it to update, And you can also be explicit about at what rate you want it to update. So this is running at 30 frames a second rather than 60.
Yeah, this would be handy for the PyPortal. Like one of the things I noticed was if I put a lot of text on the screen, it would refresh in the middle of the text, so it would slow down, but it would only show like a couple letters at a time.
Right.
And what's nice is that instead of spending all that time doing the refresh like 4 times while I'm putting text on, stop the screen, put all the text and objects you want on the screen, and then tell it now do the refresh.
Exactly.
And it's faster overall, even though it's faster over. It's not that much slower than individual refresh because you're not like ending up pausing and going back and forth. Yeah.
Right. So it works by default, just like before, where it will auto update for you, but you can say auto refresh off, and then it will do it only when you call it, which is
okay.
Cool.
And then what's this?
This is this is my custom Game Boy cart running CircuitPython. And what I didn't have before is this is actually Game Boy Color. It's kind of hard to see on the screen, but there is a bit of color there.
It wasn't famous for having great color.
No, but I thought it might actually be a bit better than the backlit screens, because it's not. It'll actually be better.
We can see her red hair in the blue background, and you're jumping. So yeah, it's colorful. It's 16 color palette.
So it's really tricky. Pico 8, which this game is based on, is 16 colors. I think I crashed.
Or you're just stuck to the side. She's like,
I'm having reliability issues still.
Okay.
But the challenge is that the Game Boy Color itself can do a bunch of colors. It's actually, you can think of it as RGB 555. It's that many. It's 15 bits of color. But per tile, you can only have 4 colors. Because that's kind of like the original limitation of the original Game Boy. So you can only have basically 4 colors per 8x8 square. And so one of the things I had to do is like for every 8x8 square in the sprite sheet, like figure out which colors you have and warn you if you have one that has even more in it.
All right, cool. Well, people want to see this. Can they find you at PAX West?
Yeah, okay. Let me know on Twitter that you want to do that, because I'm only there one day, and I have folks that I want to chat with there as well. So,
all right.
Yeah, definitely let me know.
Some amazing stuff coming out of CircuitPython. Everyone can't wait. 5.0 dropping soon.
All right.
Thank you, Scott.
Thank you so much, Scott.
Yay. All right. Next up, let's go to Mike B. You can give us an update on some of the guides you've been doing, and we'll get to Chris Young after that.
That's right.
Oh, Mike, we can't hear you.
Sorry, I did 2 guides. One, I don't remember this. Yes, one was on Web USB, which you can go on to learn.adafruit.com and see. The other was exploring Microsoft MakeCode and various ways of using storage. There's a storage module where you can actually read and write files to, similar to other languages. And I was playing with Circuit Playground Express with the data logger extension. And so what I'm having this do is when it's green, it's logging data, logging the temperature and the light level. And pad A1 right here, which is for a soil sensor. So this would be like a complete way to monitor a plant. So it's collecting data. Now what I found is it's best to pause data so you can access the drive. That way the file is closed, your operating system will play with it nicely. And so I'm going to try to share a screen that don't show again. Can you see anything? Okay.
Yeah.
Okay. So this is showing a flash drive. We don't. It's not going to appear as CPlay boot, meaning the boot screen. It's not going to be CircuitPy, the CircuitPython flash. It makes a flash drive called MakeCode, and so there's like the CircuitPy drive in CircuitPython. There's some text files that kind of show you what's going on, and a UF2, which is the program you're running. But there's this directory called SPI Flash, and if you go into that, there's a file called log.csv. That's for the data logging. You can name in the storage module, you can name anything you want, but I think
So it's that easy. You just have a CSV and there's the data, and then you
there's
can
the files, and you can use it on anything you want. You can, for example, this is the logging. I just logged some text with the values, but if I click the CSV file, which is just the numbers with commas separating them.
Well, I think for more details, they can check out your guide for how to plot it, import it, and all that good stuff.
Definitely. It's all laid out, and it's spelled out very quickly. I don't know if the...
Okay.
Okay. It's not... It likes you to copy things off before Excel.
Yes. Check the guide for all the... check the guide for all the details, because you wrote an excellent guide, and we'll also talk about it on the show.
That's right.
Okay. Next up.
All right. Thanks so much, Mike.
Thank you, Mike. All right. Next up, let's go to Chris Young.
Can you hear me?
Yeah, we can hear you, and we can see your screen.
Okay. This is a infrared transmitter board that I prototyped way back in March of 2013. And it was back when I was first getting involved in infrared. And I showed it on the show and tell on March of 2013. Here's a schematic for it. I put 4 LEDs because I didn't know if 2 was going to be enough. It's kind of loosely based on the output portion of the TV Beacon. And this was the EagleCAD board. This was the first circuit board I ever designed back in 2013. And here's one of them constructed. It's still in use today. This was a ray tracing rendering I made of the board. It was all, I modeled the parts myself. I thought it looked pretty good. You guys were all impressed with it. But now we fast forward, and this is the 3rd revision of the board, and that's a Fusion 360 rendering of it. And it's got 2 LEDs and 3 driver transistors and a couple of receivers. And here's the schematic, again in Eagle. There's the board. I've added some extra power and ground pins because sometimes I'm hooking it in with other components, and it just is handy to have some extra pins I can stick things on to. And here's a learning guide for it that was just published this week. I'm building an infrared transmitter and receiver board. And this is all in preparation for a massive tutorial that I'm writing about my assistive technology ultimate remote. And this is just one component of that project, and I thought it deserved a guide of its own. So I'm about halfway done with that mega guide on the ultimate remote, and this part is all finished. Big thanks and a shout out to Bill Banco, who made an assembly video for me and showed how to assemble the board, and then I narrated it. And we're going to go do the same thing for the ultimate remote. And so here's the board that Bill built for me, and it looks really nice. And as always, for more on my projects, go to tech.cyborg5.com. Join us on the AT Makers Facebook page, and of course, the guide is on the learn.adafruit.com.
Yeah, it's a great guide, and we'll talk about it on the show as well. You're like the expert of IR. You're like by far the person who knows the most about IR decoding and encoding. So it's good to have you making hardware for people to use it with.
Yep.
Thanks so much, Chris.
Thanks, Chris.
All right.
All right, next up, let's go to Chris Schmitz. Sorry.
Hey.
Hey.
Hey, Chris.
Okay. I have a couple of things to show off.
Okay, it'll take 2-3 minutes to show what you got.
Okay, cool.
You always come back.
Okay. The smaller thing that I'm working on at the moment is an acrylic nightlight that I made a year ago when Tech Shop was still open. It's laser cut out of acrylic and plywood, and then this version uses a NeoPixel stick and AT Tiny to run just like really simple light patterns. And I designed all this in Illustrator last year, and that's a big pain whenever you're laser cutting because you have to account for the material widths for all the tabs and stuff to put together. So I'm working on a new version that I modeled out in Fusion 360 and tied all the material widths to variables so that I could go through and quickly adjust the size and stuff like that. So this one's eventually going to run off of Trinket M0 because I want to put a capacitive touch pad on here so that it can run just whatever light pattern by default, and then whenever you touch it, it does some other kind of light pattern, or maybe I'll put a speaker in and put sound or stuff like that. So, and the larger project that I'm working on, there's a prototype for a Plinko machine that can tell what disc you're playing with. So whenever you go through and play, it does the regular thing like light up the gate that you went through, and there's a little spinner down in the bottom that is kind of a placeholder for a thermal receipt printer that I'm learning how to program now. But it can tell, like, it changes the color of the spinner based on which tile you play with, and the idea is that each of the tiles or each of the discs will have nouns on it. And each of these gates is probably kind of hard to see in the video, but there's a verb written on it, and there's going to be artwork printed out that is the combination of the verb and noun. And there's going to be a mascot that will be doing the verb with the noun that you pick. So you could be like, it could be the mascot eating a cupcake, or sitting on a cupcake, or wearing a cupcake, stuff like that. So, both of these were laser cut. This one was a lot of hand cutting, laser etching for the tiles. And then there's, like, if I can get it turned around, there's actually two microcontrollers running this. There's a feather that's handling the main game logic, and then a trinket that's running the light patterns for the LEDs, the gates, and then the speaker, which, like, I turned the sound down because I don't know if you can hear that or not, but it's just like tones running to do the sound effects. So the final version is probably going to have a feather and then a couple of AT tinies to kind of like logically separate out the lights and sounds and stuff. So yeah.
Great work. Yeah, the only thing these projects are missing is an as seen on the show and tell sticker. Don't forget to email support@adafruit.com for your show and tell sticker. Good work.
Beautiful. I love the nightlight. It's simple, but it just looks so great.
Yeah, this was one of the first like hardware projects I tried making. I've only been doing this for like a year and a half. So.
All right. Thank you so much.
Okay. Thank you, Chris. Okay. Next up, Matt Costi, play us out.
Hey, how's it going?
Hey.
So I've gotten some more progress on my pixel stick. So the last missing piece I had was a way to mount a battery to the build. So I designed and printed out this kind of like a hose clamp that can attach to the 2020. And so this would just like slide right in. I can tighten up this bolt, and then it's good to go. And then, so I already had this, but I wanted to give it a closer look. So this is the housing that I have for the feather and then the ESP32 breakout. And then I also modeled in a snap fit case. So that just goes up here and snaps in. These are my first two like really involved CAD models before. So I hadn't really done this before. And then the last thing I want to show is I actually, now that I have a battery and the whole thing is portable, I actually was able to go out in the field and take some pictures with it, which was really exciting.
Let's see the pics.
Can you guys see my screen?
Yeah. Ooh.
Oh, it's good.
Right.
Mark block.
So this is just what the build looks like, and then when it's all assembled. This is my first picture. I had to do Hello World.
Looks great. More pink than usual.
Question mark block. And then at the end, I was just playing around with just rainbow effects.
Looks so cool.
Very cool. Well, as always, email support@adafruit.com and you can get as seen on the show and tell sticker, or you can just take the graphics and paint it out in the sky. Dealer's choice with that.
All right. Well, it looks
All right.
amazing. Good work. And I know that the cell phone interface is the really powerful part. So it's you definitely taking it one step further.
Yeah,
Thanks so
All
much.
right. Come back and show us as you do more with it.
will do.
Okay, cool. Thanks, everybody.
All right, that's our show and tell tonight. Thank you, everybody, for making this the best 25 minutes of our week. Every single week, we'll be doing Ask an Engineer in just about 5 minutes. We'll get set up here. We'll be back next week, 7:30 p.m. Eastern Time. If you were on the show and tell and you want a sticker, email support@adafruit.com. If you're a kid, please have a guardian-like entity do that for you. See you in a couple minutes.
Not like a Zelda guardian, like a human guardian.
Yeah. Bye, everybody.
Bye, everybody.